In Chapter 3, we worked with linear regression a little bit, where we could write an equation, or our calculator, we could have our calculator write an equation, trying to fit some data. And we're going to do the same thing here, but instead of having a linear function, we have a quadratic function. So we're doing quadratic regression here. With this data, this table shows a meteorologist's predicted temperature for a summer day in Denver, Colorado. What is a quadratic model for the data? Predict the high temperature for the day. At what time does the high temperature occur? Okay, there's a lot of questions here, but really right now we need to focus on what is the quadratic model for the data. So to get started, we first need to figure out what is going to be our x value and what is going to be our y value. So our temperature, in theory, changes as our time changes. Okay, so we want L1, our x values, to be time. And we want L2, our y value, to be our predicted temperature. Okay, one thing that we need to be careful with, though, is if we just use these x values, 6, 9, 12, 3, 6, 9, that would mean we have two temperatures fitting with 6 o'clock, and there's not really a way there to differentiate between 6 a.m. and 6 p.m. So that being said, we are going to use a 24-hour clock, or army time here, to write our times out. So 6 a.m. would be 6 in army time, 9 a.m. is 9, 12 p.m. is still 12. This over here really should say 3 p.m. 3 p.m. would be 1500 hours. 6 p.m. would be 18, and then 9 p.m. would be 21. So when we enter this data in our calculator, let's find which is going to fit, like what our calculator screen should look like. And then once we kind of realize what our calculator screen should look like, we'll go back in and we'll go through this process to how we put our data in our calculator. Alright, so we already said we had to change to the 24-hour clock, and that eliminates our first option here. And then between these two, 6, 9, 12, 15, 18, 21, our x values are the same. At 6 a.m. though, our temperature was 63 degrees, not 76. So our middle screen is what our calculator should look like. Now, how do we put this in our calculator? How do we put our data in? We go to Stat first. So the same process that we used for linear regression, we go to Stat and Edit. If we want to clear out our data that's here, remember we go to L1 and do not hit delete, hit clear and enter. Same thing over to L2, clear, enter. So I'll make that note here, clear, enter, to clear any data. It's there. Okay, so we put our values in. We wanted 6, 9, 12, 15, 18, and 21. So your calculator should look like this. Now I can go back to Stat. Over to Calc. And since we want to make a quadratic function to fit this data, we want, right here, option number 5, quad reg. And it's already set, so I have list 1 and list 2 here. Go down to calculate. here are my values. Okay, so we see A equals negative 0.329, all of these digits, B and C. Now, when we are writing our equation based off regression, the more that we round this, the farther off our function will be from our data. So really, the more digits, the better. And I'm going to keep that in mind when we go to actually write out our function here. So writing our quadratic model, so y equals negative, I guess I'll move my calculator because we can see the numbers here anyway. Y equals negative 0.3294 x squared plus 9.7976x plus 15.5714. And like I mentioned, too, the more digits, the better. As far as rounding goes. Okay. All right, so we got our quadratic function. Now let's look at what else we were supposed to find. We got our quadratic model. Predict the high temperature of the day. At what time does the high temperature occur? Well, if I'm trying to find my high temperature, based off my equation, what do I have to find? Well, the highest is my clue that we need to find our vertex. So right down here, I'm going to find the high temperature. And keep in mind, in standard form, the x-coordinate of our vertex is negative b over 2a. And I have my b and a values for my equation here. So negative 9.7976 over 2 times negative 0.3294. So this is negative 9.7976 over negative 0.6588, which ends up being 14.872. Now, is this my temperature? No, this is giving me the x-coordinate of my vertex. And x values in my problem are representing our time. So this tells me that my high temperature was just before, well, 1500 hours in our Army timer, our 24-hour clock, was 3 p.m. So our high temperature was just before 3 p.m. To figure out our actual high temperature, we'd have to plug in our x value into our equation. The y-coordinate plug in our value, negative 0.3294 times 14.872 squared, 9.7976 times 14.872 plus 15.5714. And you can type this straight into your calculator just like this. And I'll save you the effort of doing this, but it ends up being 88.4 degrees as our high temperature. So the high temperature is 88.4 degrees, and it occurred just before 3 p.m. Now, one thing I want to point out, if you look back at our table, our table is showing that we reached a high temperature of 89 degrees. Well, keep in mind that this is, first of all, our meteorologist's predicted temperature. And one other thing to keep in mind is that our quadratic function that we're getting from regression doesn't fit all of these points perfectly. It gets as close as we can, but it doesn't fit our data perfectly. So even if we had, even if these were temperatures that actually happened, and instead of our equation modeling the predictions, if our equation modeled the actual temperatures, there's still that chance that we could have gotten the fact that our temperature, from our equation, that our high temperature was 88.4 degrees, when really it actually got up to 89 because of a little margin of error. But quadratic regression still helps us to fit our data pretty well.